Alright guys, so we are officially starting storage management in Linux today. And storage management, we are going to approach it in two parts. And the first part will be this partitioning, and the second part will be volume management. And in this partitioning, which is what we are starting with right now, we want to learn how to partition a hard drive into different partitions. And the reason you might want to do that is because sometimes you want to store certain types of files in a separate hard drive. And partitioning a drive, you're basically creating partitions which are going to behave like separate hard drives. So that is one reason why you might want to create partitions on a drive. And another reason could be that you want to assign specific amounts of hard drive space to different departments in the company. So for example, let's say that you have a 2 terabytes hard drive and you want to assign 500 gigabytes each to the finance and management departments and 1 terabyte to the engineering department, then you will have to partition the drive. So when you create a partition on a drive, you end up with a raw partition. And a raw partition simply means that it's a partition that does not have a file system on it yet. And what is a file system? A file system is basically a tiny piece of software that you attach to a hard drive. And that software defines the way in which bits of data are arranged on the hard drive. So we have so many different types of file systems, but we are going to limit ourselves to the ones that are important for our class. So the first file system that we will be looking at is the extended file system, EXT, and it exists in versions 1 to 4. 4 is the latest version, and that is the one we are most interested in. And then we also have the XFS, which stands for just X file system, and that is the default file system in Red Hat 7 and 8 and 9. And then we have the FAT, file allocation table file system, which is the default file system in very old Windows versions. And then NTFS is the new technology file system, which is the default file system in Windows Server 2012 and newer. And then we also have NTFS and CIFS, which are actually file systems that work by using your network. So NFS stands for Network File System, and we will use that to create network shares on one server and mount those shares to different servers. There is also CIFS, which is a Windows equivalent of NFS, and it's called Common Internet File System, and it is used to create Samba shares. And we will be looking at what Samba shares are. So there are three tools that you can use to create partitions on the drive. We have FDisk, we have Parted, and we have GDisk. Okay, so when you use any one of these tools, you basically have to create a label on the drive. Okay, so there are two possible labels that you can give a drive. One is the MBR and one is the GPT. So MBR works by using the 32-bit system, and GPT uses the 64-bit system. And a major difference between the two is that with MBR you can only create up to 4 primary partitions, whereas with GPT you can create up to 128 partitions on a drive that is assigned the GPT label. And also the MBR label does not allow the creation of partitions that are more than 2 terabytes. So if you want to create a partition that is more than 2 terabytes, then you definitely have to label your drive with a GPT first before you can create that partition. So let's go ahead and demonstrate how this works. Let's just jump over to my system here. I have my CentOS 8 running, so I'm just gonna log into the root account and obtain the IP address, and then go sign in to that server from Porty, because Porty of course is more convenient than working on the server itself. Okay, 190 is the IP address, so I'll open up my Porty and bring it over here, and I will type in the IP address of my server, and click open, and then I will log in as root. Okay, so it takes a little bit of time to let me in, and all we can do is just wait. So let me adjust the font so that you can see a little bit clearer. Okay, so this is my server. If I do LSBK, which stands for list block devices, blocked disks or hard drives are treated as block devices. So I'm just saying list the block devices that exist on this system. So we have one block device, SDA, and SDA is our operating system hard drive. That is the hard drive that we assigned to the system, to the server during installation. You can see the size is 30 gigs. And this hard drive, the operating system created two partitions on this drive, SDA1 and SDA2. And SDA1 is mounted under /boot, and then SDA2, the operating system actually used it to create a volume group called CS, and under CS it created a logical volume called root and another logical volume called swap. And we are not talking about volume groups and logical volumes right now. That will come in the second part of storage management. Okay, so right now we only have one hard drive on our server, and that is our operating system drive, so it's better to leave it alone. So in order to manage to create partitions, we need to add a hard drive to this server. We need to attach a brand new hard drive to the server, and the only way to do that is to start by shutting down the server, because you cannot add a hard drive to a server that is up and running. The server is not going to be able to detect that. So you shut the server down. and then you go and attach a new hard drive to the server. So this is my virtual box. I have my server highlighted, School CentOS 8, and I'm just gonna click on settings. I want to add a hard drive, so I need to go to storage, and we are using the SATA controller. We want to add a SATA drive, so I will click on add hard drive. The other option is to add an optical drive. We don't want that, we want a hard drive, so I will click on that, and I will select create, because these hard drives actually belong to some servers, so we don't want to touch those. So we will have to do a create, and next, and just make it 8 gigs, and finish, and it's selected, and then click on choose. And let's just add another one. Create, next, 8 gigs, finish, choose. Okay, so now we have 2 extra drives on that we've attached to our system. So I will click on OK, and then boot the system up with the new drives attached. Okay, so my party has disconnected because I shut the server down, so I'm just gonna right click on the top of my party and select restart, and log in again as root. Okay, and if I do LSBLK again, now I have SDA, SDB, and SDC. So these are the 2 brand new hard drives that we just bought and attached to our server. Okay, also drives are normally stored in the dev directory, that's devices directory. So you can do SD star and press enter. Asterisk basically means anything that has the first 2 letters that are S and D, I want to list that. So whatever is in the 3rd position, I don't care, so long as it starts with SD. So these are the drives, these are the brand new ones that we added, SDA, and its 2 partitions. So you can also do fdisk -r to list the drives. So these are our operating system logical volumes. You have SDC, SDA, and its 2 partitions, and you have SDB right here. So let's invoke the fdisk command to add on SDB. So we will do fdisk dev SDB, press enter, and now SDB has been selected by FDIS and it is ready for us to instruct it to perform actions on dev SDB. So for the help, if you don't know what to do, just type M and press enter, and you have all the options here. And you have D, which is to delete, N is to add a new partition, T is to change a partition type, and M is to print this menu, and W is to write the table to disk and exit, and Q is to just exit without writing. So what do we want to do? We want to create a partition, so we will do N, and we want to create a partition, a primary partition, so we will type P, and it already knows that it can only create up to 4 partitions, so, and it knows that this is the first partition that we are creating, so it defaults to 1, to partition number 1. So we just press enter, and it's gonna select the start of the disk, first sector. So a hard drive is actually made up of sectors. So because this is the first partition, it's gonna start from the first sector, and you can see the range here. So this particular hard drive, the sector starts from 2048 to this number, this long number. So if you take this number minus 2048, that should give you the total number of sectors that exist on this disk. Okay, so we want to start from the first sector, so the default is the first sector, so we just press enter, and then you can, there are several ways to do this. You can do, if you want to do it by sectors and you know exactly which sector you want to stop at, you can basically put that sector here, last sector. However, we will hardly ever use that because that is hard to get. So instead we will use plus. We are saying that start from the first sector and then add from there, add 2 gigs. So you can do it plus size, either in kilobytes, megabytes, gigabytes, terabytes, petabytes. It's up to you. So we do plus 2 gigs because our disk is only 8 gigs in size. So we press enter, and it creates the partition. And then the next thing is to write it. So we do W to write the information to the drive, because right now the partition that we created exists in memory. Remember that memory is meant to hold information that is open. So right now what is open is the FDIS2, and everything that it is doing is being stored in memory. And then in order to persist whatever we did, we have to write it to the hard drive by using W and just press enter. Okay, so that has been created. So if we do LSBLK again, you can see that now SDB has a partition SDB1 of 2 gigs. Okay, so the next thing will be to format this partition with a file system. So let's format it with ext4. So let's do mkfs, which stands for make file system, and then -t is to specify the type of file system you want to use, and we want to use ext4, and the device that we want to use the file system on is /dev sdb1, and press enter. and the file system has been created. The next thing is to mount the file system. So we have to first of all create a mount point, which is a directory that that allows for access to the new file system. So I will do make dir let me just say data and press enter, and then I will do mount -t. The mount command is used to mount file system. Okay, so I'll do mount -t ext4 dev sdb1 data. So you do the mount, and then the type of file system you want to mount, and then the file system, and then the mount point. Okay, press enter, and now if you do df-h, dev sdb is mounted under /data, and you can see that the file system is actually showing up as 1.8 gigs. 1% has been used, and that's just the file system. The file system that you put on the hard drive, which instructs the hard drive how to arrange data on it. That file system actually takes up a little bit of space. That's why your file systems will never ever be exactly the same size as you created them, because once you do the formatting with a file system, that file system does take up a little bit of space. Okay, so now we have dev sdb mounted under data. However, if you were to reboot this system right now, this file system will not be mounted. And the way to make sure that it does get mounted is to put it in the etcfs tab file. So if you do cat etcfs tab, these are the operating system file systems that were mounted. So we have dev mapper cs root, which is the root logical volume, and then we have the boot partition, and we have the swap. Okay, so what happens is when you reboot a system or when you start up a system, at some point during the start process, the system is going to check this file to look for file systems that it needs to mount before giving you the login prompt. So if your file system is not mentioned in this file, during a boot process, that file system will not be mounted. So let's go put our file system in this file. And before we do that, let's talk about BLK ID. BLK ID, this gives the unique the universal unique IDs for the file system. Okay, so you realize that we assigned 2 new hard drives, and the system decided to name them SDA and SDB in an arbitrary order. So nothing guarantees that when you reboot this system, what is SDB now will still have the SDB name, or what is SDA now or SDC now will still be SDC. Because each time you reboot, the system can decide to reverse the way that it names those drives. what is SDB now can become SDA after a reboot. But what never changes is the universal unique ID. So if you go into this file, let me go into dev sdb etc fs tab. Okay, I can put my information there. So the first thing is the file system. The next thing is the mount point. And the next thing is the file system type, ext4. And then the next thing is just defaults, 0, 0. So that's it. I can do this. And there is a chance that this system, after a reboot, that a drive that is SDB now will still be SDB. In that case, my file system will be mounted. But there is also a chance that what is SDB now may become SDC in the next boot. And if that were to happen, then my file system will not be mounted. However, what never changes is the universal unique ID. So instead of using the file system by its name, we will use the universal unique ID instead for regular partitions only. This one, the def mapper CS root and def mapper CS swap, those are logical volumes. They don't have that problem of changing names. It's not possible with them, so we can use their names in this file. This one is a regular partition. This is actually, I think, is SDA1 or A2, which is mounted, which is the boot directory, the boot file system. So let's go find the universal unique ID for dev SDB1. So I'm just gonna exit out of here. And I'm going to copy the universal unique ID for dev SDB1. Okay. And I'm going to go back into that file. And place it there. Okay. And place its mount point, its file system type, defaults, 0, 0. So these are the mount options. I'm going to make a separate video just to explain this default and this 0 and 0 separately, or either I will explain it more in class, but for now let's just use them the way they are, default 0, 0. Okay, right and quick, and make sure to check. So you do mount -a, which means mount everything. So this command is going to go into that file and look for the file system and just mount everything that is in that file. Okay, so the recommended way will be for you to not even use the mount command, just put the information of in that file and do a mount -a. That's mount all. And if there is an error in that file, it's better to catch it right now, because if you reboot the system and that file has an error, the system is gonna try to mount the file systems in that file, and the error is going to prevent the mounting, and in that way the system is going to keep trying to boot forever. So you'll see the system, the server, it's just going to keep trying to boot. You see it loading like it's trying to boot, but it will never give you the prompt to log in, because it's trying to mount a file system and the file system is not put in correctly and it's not being successful in mounting that. So this is the time that you can catch such an error. If you do mount-a and there is an error in that file, it's gonna show you that there is an error. I did not get an error. Now I'm confident that if I reboot my server, it's gonna boot normally. Okay, so that is that with fdisk. So the next thing is, how do you unmount a file system? How do you remove a file system? So the first thing will be to remove its entry from fstab. So again, you just vi into fstab. Look for the line that corresponds to the file that you want to remove, and just press dd and exit, right and quit, and then you do, the file is actually still mounted, you just removed its information from the fstab file. It's gonna be unmounted if you reboot the system, but you don't want to reboot the system, so you do your mount /data, and if you do df-h, that file system has been unmounted. And then you just run the fdisk on dev sda, and then you delete the partition that has the file system. D is to delete. I want to delete the first partition, and it's gone. I just destroyed my file system. I did FSDA, which is my operating system. So what I just did right now, I have deleted my boot file system. This. So I've basically destroyed my computer. But thank God I've not returned yet to the hard drive. That information, that removal is still in memory. So I can just quit and my system will be fine. If I had written, that would be it for this server. So SDB, not SDA. D. Okay, so the partition has been deleted, and right, and it's done. LSB, okay. Def SDB has no partition. And that is how you create a file system and mount it. And that is how you destroy and remove a file system. Alright, so I'm gonna record another video within the week to demonstrate the usage of the remaining other tools, which are Parted and GDisk. Have a good weekend and stay blessed.